All right, here we are at our 8.4 set of notes. Here we're looking at the circumference, arc length, and area sectors. And so to find the circumference for a circle, we know that it is 2 pi r. And that 2 pi r really comes from thinking about the perimeter for around a circle. And so that's essentially what you're finding is the circumference around a circle, or really just the perimeter for a circle, or how long it takes to kind of go around that circle. So for example, one, we have the circumference for a circle has a radius of 9 centimeters. Well, again, our equation is c equals 2 pi r, and our radius is 9. So we're going to go ahead and plug that in for our radius. And when we do that, we have c equals 2 pi times 9, which then comes out to be 18 pi. Next up, for B, it says find the radius. So now we're actually trying to figure out what the radius is, but we do know the circumference is 26 meters. And so the equation for a circumference doesn't ever change. It's c equals 2 pi r. And our c value is actually given this time. So c is 26 meters. So we're going to go ahead and plug that value in for the circumference. And now if I'm trying to get r all alone, we're going to divide this 2 pi on both sides. Over here, the 2's cancel, the pi's cancel, so the radius is all alone. And then at this point, we really just have to calculate it. Now keep in mind, the set on the numerator is 26, and then the set on the denominator is 2 pi. So make sure you include those parentheses as you guys go to calculate it. And so then when we go to clean this up, we end up with 2 goes into 26 13 times. So really you could just enter 13 divided by pi. And then when you do that, you get a radius of about 4.14. Okay. Oh, and then that would be meters. And then for this guy, it looks like centimeters. Okay. Now go ahead and give it a shot. Now be careful on example 2 because you're finding something else. Go ahead, pause the video and try those two. All right, so for number 1, we're trying to figure out the circumference of a circle with the diameter of 5. So then that means our radius is 2.5. And the circumference equation is 2 pi r. So now we can go ahead and plug these values in. So c equals 2 times pi times our radius 2.5. And so as a result, our circumference comes out to be 2 times 2.5 is 5 pi. Now you can also, there is another equation. It is pi d, and you can find the circumference that way. So you could have just plugged in d for the 5. But generally, I like the radius because you just kind of use it with a lot more formulas. And so as a result, there's usually then less to have to memorize with different variables. For example 2, we're asked to find the diameter of a circle with their circumference of 17 feet. So c equals 2 pi r. And again, our circumference is 17. So we're going to go ahead and plug that in. And then to find out the diameter, well, since we're actually specifically looking for the diameter on this one, we're going to use the pi d one. So instead of the 2r, we're going to just have, again, think about a radius. Well, if you double it, then you get your diameter. So I'm just going to go ahead and make that then our pi d. Now, if I want to solve for pi or for d, I would just divide both sides by pi. Boom, boom. D is all alone equals, and then that value in the calculator comes out to be 5 points, about 5.41. Okay. Go ahead and feel free to pause the video if you have any questions on those. You try it 1 or 2. All right, so that was dealing with circumference around an entire circle. Now we're going to be shifting gears towards arc length, which is really just a portion of that circle. Now, we've talked about in the past that a circle has a total of 360 degrees around. And if we want to figure out the arc length, or in other words, part of your circumference, then what you need to do is have this coefficient where you have your arc length divided by your circumference. So whatever your central angle is divided by 360. So you're actually going to use your angle measure as part of your central angle. So by central angle, we mean this part right here. Okay. So that would be kind of that angle that we're really looking at to kind of help guide us into what is this arc length around. And again, the reason why this ratio exists is because the central angle is always out of 360, because we would then go one full revolution, but we're not going to be going an entire revolution. So that's where that central angle creates that ratio out of the 360 then. Now, again, this is where you're using degrees on top, but on the bottom, we also sometimes see situations where we're talking about the 2 pi r, just kind of like how we saw a moment ago when we were looking at the circumference around an entire circle. You can then find the arc length over that entire circle to then find an angle measure itself. So let's kind of see these in action. Pretty much, guys, it's what you were doing a moment ago. It's just now you have a central angle that you're actually multiplying it by that value over 360. So let's see it in action. For example A, we have arc length, or we're trying to find arc length AB. We're trying to figure out this red arc length. Now we notice that we have 60 degrees there. So we have 60 degrees over a total 360 degrees. Now, for the arc length, AB, that would create that proportion where we don't end up with the whole circumference itself. And then what we need to do is essentially what we were doing a moment ago. We're going to multiply this by 2 pi r. And so we're going to plug in our values. Again, really, guys, the only extra addition to this is this 60 over 360 out in front. And the 2 pi times our radius here is 8. So normally you would find, okay, that's 16 pi. That would be for a full revolution. But for us, we only have a part of it. So these zeros can cancel. I'm just kind of simplifying it up here. And then 6 over 36 is the same as 1 over 6. And then we can clean that up even better. So our arc AB, we can divide the top and bottom both by 2. So then that would be equal to 8/3 pi. So if we went all the way around, we would have had that 16 pi. But because we're only looking for this portion of it, it cut down, by a 1/6 essentially. But this is our final arc length right here. Go ahead, feel free to pause the video if you have any questions at all. All right, now looking at B, trying to find the arc length of PQ. So again, PQ, this arc length is equal to the 75 degrees. That's acting as this central angle right here. Okay. So we have 75 degrees. We know that there are a total of 360 degrees in a triangle, or in a circle, times the 2 pi r. And in this case, well, they're like, hey, your diameter is 9 yards. And so our radius is going to be 4.5. Now we can go ahead and plug in our values. So we have 75 over 360 times 2 pi times 4.5. And cleaning this up, we have 9 pi for the second half. Let's see, we can divide the top and bottom both by 15. So we can again divide top and bottom both by 15. And you would end up then with 5 over 24. And then just kind of cleaning this up a little bit, there's a couple different ways you could do it, but we'll keep it simple. So we got 45 pi over 24, and then that can actually be reduced even further. So we can divide top and bottom both by 3. So then that would be 15 over 8 pi. So that would be your arc length for PQ. Go ahead, feel free to pause the video if you have any questions on B. All right, I would love for you guys to sincerely pause the video, give this guy a fair shake, and see what you end up with and see if our results match. All right, for our arc length for C, we should have ended up with 115 over 36 times the 2 pi r. We plug in our radius. Right here, I just kind of cleaned up the 115 over 360 and multiplied that 2 times 13. So we get these smaller fractions to have to deal with. And then here we multiplied the 23 that we got as a result on top and the 72 on the bottom. We multiplied the 23 and the 26 to give us the 598 on top over 72. And then we just divided the top and bottom both by 2. So our arc length for AB is 299 over 36 pi. Feel free to pause the video if you have any questions at all. All right, at this point, guys, I would love for you guys to please try 1 and 2. Go ahead, find arc length AB and CD. Pause the video and give them a shot. All right, looking at number 1, we have 120 degrees over 360 degrees times 2 pi times the radius is 6. And so this can actually be reduced down to 1 over 3. You can divide the top and bottom both by 120 there for that degree part times 12 pi. And so we end up with 12 over 3 pi, and then that just simplifies down to 4 pi in the end. So there is our arc length for AB. Shifting over to number 2, again, super similar here. Our diameter is given as 24. And so you could use the pi d, but again, I kind of like that 2 pi r. So the circumference is equal to, I'm sorry, not the circumference, the arc length. Our arc length CD is equal to 60 degrees all over 360 degrees times the 2 pi r. And so we can plug in our value. We know our radius is half of this. So since it's 24, it'd be 12. And so I know you guys are going to double it again anyway, but it's kind of just, you work with a lot of radius instead in geometry. So this would be 12. And then the 60 over 360 actually simplifies down to 1 over 6. And now we can kind of clean this up a little bit further. So we have 2 times 1 times 12 on top, which would give us 24 over 6. And then pi is up top as well. And then finally, that would simplify down to 4 pi. Oh, look at that. They came out to be the same result. go ahead, feel free to pause the video if you have any questions on the You Try It 1 or 2. All right, next up, a circle has a circumference whose length is 25 pi. And then we're asked to find the length of an arc whose central angle is 90 degrees. Okay, so there's actually two approaches to this. Again, our circumference for the entire thing is 25 pi. So we know that. 25 pi. Ugh, let's rewrite that. That looks horrible. 25 pi. Now there's, again, really there's two different ways to take this. I'm going to kind of show you the legit way. It's more universal. So here we got our circumference. We know is 2 pi r, right? We don't know how big the radius is, but we can very quickly find it. So our circumference again is 2 pi or 25 pi. So we're going to dump that in. And now we're going to go ahead and solve for our radius. Now to do that, we're going to divide both sides by 2 pi because we want to try and get our radius all alone. And so when we do that, our 2's cancel, our pi's cancel, r is all alone equals, on the left side, our pi's cancel, and then we're left with this 25 over 2, and then that really simplifies down to 12.5. So our radius is 12.5. Now we can use what we were using a moment ago. And so recall, to find the arc length, so I'm going to call this just arc, I guess, since we don't have any letters. So our arc length is equal to our degree measure, in this case 90, over 360 degrees times the 2 pi and our r. And now we know the radius. Before we weren't able to do that. So here, this will actually simplify down to 9 over 36, or 1/4, times 2 pi times the radius, 12.5. We'll go ahead and we'll multiply the 2 times the 12 times the 1 on top, and we end up with 25 pi on top over 4 on the bottom. And then boom, there is your arc length. There is our arc length. Now, this way is a fantastic way because there might be some questions where they're like, hey, find the radius, right? And then find the even arc length. Now, what do you do though if, for example, again, there's a faster way. So let me pause and start with that. Notice that you have 90 degrees, right? 90 degrees. Well, out of a circle, there's a total of 360. So this arc length is 90 degrees, using 90 degrees, is 1/4 of your entire circle. So imagine you have your full circumference, the full way around it is that. And because we're doing 90 degrees, well, that is 1/4 of a full revolution around a circle. So it's 1/4 of that. And so that's where you end up with the exact same answer, 25 over 4 pi. That's kind of like a shortcut way, though, because we're not always blessed where we have 90 degrees or things like 180 degrees. So, yes, that's nice and handy. This way is way more universal that you'll be able to use, okay? So I would definitely know the top way. But it's good to see that they do in fact. All right, for number 4, we have to find out what this arc length is. And so go ahead, pause the video and give it a shot. All right, so for number 4, we're trying to figure out this arc length xy. So xy is equal to 70 degrees over the total 360 degrees times our 2 pi r. So radius here is 10. And we can kind of clean this up. We can divide a 0. And so we get 7 over 36 times 20 pi. And then even just kind of like a quick shortcut, for some of us that are able to see this, we can divide the top and bottom both by 4 here. And so if we divide this by 4, you'd have 9. And if you divide that by 4, you'd have 5 instead now. So just kind of, instead of multiplying the 7 and the 20 and getting a big number and then simplifying it, it's kind of shortening that with smaller values. So our 7 times 5 on top, we end up with 35. And on the bottom, we have 9. And our pi is on top. So our arc length for xy comes out to be 35 over 9 pi. Go ahead, and again, feel free to pause the video if you have any questions there. All right, now we are moving on to area of a circle and then eventually sectors. So the area of a circle, you guys have seen this famed equation, area equals pi r squared. And so we're going to go ahead and just kind of lead into that just with a couple of examples, just kind of refreshing those skills. So the area of a circle has a radius of 2.5. So again, our area for a circle is pi r squared. I always like to write down the formulas just because then it helps me remember all the different ones, because believe me, you're going to see a ton of them in high school, and it just really helps keep track of what's what. So our area equals pi times radius is 2.5 squared. And then our 2.5 squared comes out to be 6.25 pi. So there is our area. Now for B, it's saying the diameter of a circle has an area of 113.1 square centimeters. Oh, and this would be centimeters, by the way. Square centimeters. And so we're trying to figure out what is the diameter of this item. But we do know that the area is 113.1. So again, area equals pi r squared. And so to do that, we're going to have our area as 113.1 equals pi r squared. And we're going to divide both sides by pi because our goal is to try and get r all alone. So we're going to get rid of this pi on both sides. Okay. And then we're left with r squared equals 113.1 divided by pi. Comes out to be this long, weird decimal. For right now, we're just going to call it 36 because it's just like 36.00084. So there's, just, it's pretty much just 36, and especially for the sake of this example. Then lastly, we're going to take the square root of both sides. So the square root come together with the square, they cancel out. R is left alone equals 6. So our radius for this guy comes out to be 6. Well, that's fantastic, but it seems to actually want the diameter. So just multiply by 2 and boom. C or D equals 12. Okay. And that would be 12 centimeters. So just be careful what the question is really wanting. Okay, make sure you pay attention to what they're really asking for. All right, so now that you've seen an area, you've found a diameter. Go ahead then and try these U-triads. Pause the video and give them a shot. All right, looking at number 1, we've got the area with a radius of 4.5. Again, area equals pi r squared. And we dump these items in. We've got 4.5 quantity squared. And then, squared. Our 4.5 squared comes out to be 20.25 pi. And boom, there is your area. So 4.5 squared is 20.25. Oh, and then that would be meters squared. because we're talking about an area here. Next up, here we have to find the radius. So we're looking for the radius that we don't know of a circle with an area of 176.7. So area equals pi r squared. And we know our area is 176.7 equals pi r squared. We take our 176.7 and divide it by pi on both sides. And we get our r squared is equal to about 56.245 3, 5, 6, 8, 8, 8, 6, 7, 5, 8, 1. You're like, man, that's a really long decimal. Yes, it is. Sorry. But we have this equal to r squared. And then we are going to take the square root of both sides. So that value that you just got, just take the square root, and then you get a radius of about 7.5. Yeah, we try and make it as exact as we can, so that's why we use a lot of decimals to help us out. You don't have to, but you definitely want to go as far as you can for that most exact answer here, though. So the radius is pretty much 7.5. Okay, go ahead and feel free to pause the video if you have any questions at all on these. You try it 1 or 2s. All right, next up, we are going to be finding the area of a sector. Now, again, an area of a sector, it's a lot like arc length, but here we're talking about an area of a particular circle and only really part of that area. As you guys can see, it's kind of this gray shaded region that you're seeing on the screen. And it's super similar. I mean, we're really just doing that central angle over 360 degrees. And then timesing it by our pi r squared instead of the 2 pi r. That's really the only difference. So for example, here, this is a central angle. See how it's 90 degrees? It's also 90 degrees in here. They actually share the exact same angle measure. And so when we go to set it up, we have our 90 degrees over 360 degrees, because we're only doing part of the full circle, times the pi r squared part. So again, this is our sector area. So sector area. And so we can kind of clean this up. We know that you get 9 over 36, which is really 1/4 times pi. We're going to go ahead and throw our radius in here now. It's 12 squared. We'll change up colors too while we're at it. So now we have 1/4 times pi. 12 squared is 144. And so we end up with the 1 times the 144 pi gives us 144 pi on top over 4. And then we can divide that out evenly. It comes out to be 36 pi for this sector area. Okay. Generally, if you write sector, that's fine. All right, for B, here we have 60 degrees out of the full. So again, this is our sector. Out of the full 360 times pi r squared. We can clean this up. It is 1 over 6. 60 over 360 is 1 over 6 times the pi. We're dumping our 12 in there. In which case we end up with 1 over 6 times pi. 12 squared is 144, just kind of like before. We multiply the top. 1 times pi times 144 is 144 pi over 6. in which case then that would simplify down to 24 pi. So that would be your sector. Okay. So again, the sector is not a full circle, it's just a part of the circle. So yeah, that's how you find them. Next up, looking at C, it says find the areas for this sector. And it has this angle UTV. So angle UTV. But really, we're kind of just looking for this angle. The only difference here is that you have different colors. That's literally it. So again, UTV is that angle right there. So we have, for this sector, we have 70 degrees over 360 degrees times pi r squared. We dump in our r. So that is 8 squared. This will cancel the zeros. So we have 7 over 36 times 64 pi. 8 squared is 64. And then let's go ahead and clean up this fraction part first. So we can divide the top and bottom both by 4. This would be 9. And this would be 16. And then multiplying the top numbers, 16 times 7 would be 112 over 9 pi. And we can't really simplify it any further than that. So that is your sector. Go ahead and feel free to pause the video if you have any questions. Oh, for the sector, by the way, never mind. This would be sector UV, though, just so you know. All right, go ahead and try number 3 and 4, and then we'll come back together and see how we did. All right, as we look at this area of the sector, we have, again, our sector is 135. We know it's a sector because we're finding this shaded region right here, by the way, instead of an arc length. So 135 divided by 360 times the pi r squared. We know our radius is 8. And so we can go ahead and dump that in. We have 135 over 360 times the pi. Radius is 8 squared. And we can go ahead and clean this up. I know we can divide the top and bottom both by 5. And we can actually even do 15. So we can divide this by 15, this by 15. And when you do that, you have 9 over 24. Oh, and then that can be even simplified further. So, well, we'll do that here in a moment. You got pi. 8 squared is 64. And we can divide this again by 3. Then we get 3 over 8 pi times 64. And then the 3 times the 64, we'll just do it that way this time, just to kind of keep it consistent with other paths. We end up with 192 pi over 8. And then that can actually be divisible by 8 and 8 on top and bottom. And when we do that, we end up with 24 pi in the end. So that is your sector. Oh, and this would be meters. Oh, and then this guy would have been inches. All right, looking at number 4, we have our sector is equal to 40 over the 360 times the pi r squared. So for us, this would have been, this will boil down to 1/9. Pi times our radius is 18 squared. And then as a result, this is 1/9 pi times 324. We end up then with 324 pi, multiplying the 1 times the pi times the 324 on top, you would get 324 pi over 9. And then lastly, we can divide the top and bottom both by 9. And when we do that, we end up with 36 pi in the end for that sector. Again, go ahead and feel free to pause the video if you have any questions at all on 3 or 4. All right, looking at number 5, we're asked to find the areas of both the minor and major sectors. So we're going to start with the minor one. By minor, they're just talking about this guy that looked smaller. That's why it's called the minor. So we'll start with him first. So for our minor, well, the sector is equal to that angle measure 120 over 360 times the pi r squared. And it says that our radius here is 14. So the 120 over 360 will simplify down to 1/3 because we can divide the top and bottom both by 120. And our radius here is 14. Now, when we do 14 squared, we should get 196. And as a result, when we multiply our 1 times our pi times our 196, we get 196 pi over 3. And unfortunately, that can't really be simplified any further than that. Okay. Now, we've seen a lot of areas of sectors, especially of like the smaller kind. Let's see what happens, though, when we're trying to figure out this major, this major one. We'll go with green just to kind of change up the color. So we're then looking for what is this sector area? Well, again, for the major, our sector, the process is still exactly the same. So we're going to have to figure out what is that angle measure, though, because we don't know what that is this time. Well, we do know, though, that the minor is 120 degrees, right? And in a full circle, it's 360. So the leftover stuff, 360 minus the minor one, is going to give us 240. So then that is your central angle, 240 degrees. So again, if this is 120, this has to be 240 degrees. Times our pi r squared. And then it's really attacking it just like we were the others. So here we've got our, here the zeros can cancel. And then 24 divided by 36, we can reduce that down to 2/3. And then we have our pi, and our radius here is 14 squared. Again, 14 squared comes out to be 196. And then when we multiply our 2, our pi, and our 196 together on top, we end up with 392 pi over 3. And unfortunately, we can't really simplify it any more than that. So for our major, that would be your answer. Oh, and this would be in feet squared because we found an area. And then likewise, this would be in feet squared because it's an area. Okay. So all of these, actually, I apologize. This would have been meters squared. And yeah, this would have been meters squared. Okay. Again, anytime you're finding even areas of sectors, it's that, dimension squared because it's an area. All right, go ahead. Feel free to pause the video if you have any questions at all, though, on minor versus major arcs or sectors. All right, example 3. We have to figure out the area for this figure. Well, let's go ahead and start with the triangle part first. We're going to do our triangle. And we know the area for a triangle is 1/2 the base times the height. In fact, I'll go ahead and have you guys pause the video and give this one a shot, but I did kind of help you out with the area formula for a triangle. So go ahead, pause it, and see if you guys can figure this guy out. All right, now coming back together, again, this is what we call a composite figure. So we're just trying to figure out the areas and then kind of bring them together. So here our area is 1/2. We're going to treat this guy as like our base, and then this guy would be like our height. Okay. So our base is 7, and our height is 7. And so for the area of this triangle, we get 1 times the 7 times the 7 on top being 49 over 2. And so really that comes out to be about, not about, but 24.5. That would be meters squared. So again, that's just for the triangle part. Now we have this kind of semicircle, right? Well, there's a couple different ways that you can approach it. It's a half of a circle, but we're going to try and reinforce those central angles and area of sectors. That's kind of what we were studying today. Well, keep in mind, this is 180 degrees. Fair to say? When you have a straight line, kind of like the protractor, that is 180 degrees. So for the semicircle area, we have 180 degrees over the total 360 degrees. And our radius, we have to be careful here, because again, it's usually pi r squared. Our radius is not 7. A lot of people sometimes think, oh, they just kind of jump into it and think it's 7. It's actually not 7. It is half of that. So half of 7 is 3.5. So this is actually the radius we're going to use. So we now go ahead and we have our pi times our radius, 3.5 squared. And so we'll leave this alone for the moment. We'll come back to it. Pi, and then this comes out to be 12.25 in the calculator. All right, so now let's go ahead and clean up our coefficient fraction. Well, we know the zeros can cancel. And then 18 divided by 36, same as 1 over 2. Pi times this 12.25. Now we're going to multiply our 1 times our pi times our 12.25 numerators essentially together. So we end up with 12.25 pi over 2. Again, we kind of want to save the pi for the very end. And now in the calculator, what we want to do is do 12.25 divided by 2. So we're going to clean that guy up. And when we do that, we end up with 6.125 pi. So we kind of just really focused on dividing those two. And now we'll go ahead and multiply it by the pi. And when you multiply by pi, you end up with, kind of this 19.242255500, a bunch of stuff, right? 48. I know, it's a really long decimal. Now, all that you have to do last is take the area from your triangle, tack it onto this guy, 24.5, and you have your answer. Because it's a composite figure. And so when we add the 24.5, we end up with total area of 43.7422, but just 74 essentially when you round it. This is your total area. Go ahead and feel free to pause the video if you have any questions at all. Awesome. So guys, just a quick recap. Just a fast recap. We did finding circumferences, just normal finding circumferences. And then, solving for a radius given the circumference. And then arc lengths as well. Got to go a little bit higher, I guess. There we go. So we found, again, circumferences, found a radius, diameters we found using 2 pi r or pi d, arc lengths, so a certain portion of a circle's perimeter. Again, it's really, guys, it's just central angle divided by 360 and then either 2 pi r or pi r squared. Here we had some examples of those where we're finding arc lengths. And then we got to areas, area of a circle, finding a radius, diameter, and then finally the area of sectors. Okay. The main kind of takeaway, central angle over 360. And then if you're doing arc length times 2 pi r, if you're doing area times pi r squared. All right. Fantastic job, guys. And have a great rest of your day.